How are you doing, math learners? This is your free access math teacher Ash, and welcome to ML with Sir Ash. For today's lesson, we're going to discuss a topic that is both discussed in the grade 7 and grade 9 mathematics, and this is all about the law of exponents. In this video, you will learn the 5 rules that pertains the law of exponents. If you don't know and the technique behind this topic, I suggest you finish this video. But before anything else, hit that subscribe button and notification bell for you to be updated of these school clear math videos just like this. Hello math learners! Welcome to another session here in Math Learning with Sir Ash. Today, we're going to discuss the most essential learning competency-based lesson for quarter 2 of the grade 7 as well as the grade 9 mathematics, which is all about the law of exponents. Question is, what is an exponent? Exponent is the small number that is being lifted from a given expression, variable, constant, or any number. Example, if we have this given, the exponent is the little number here, the 2. Exponent is also known as the power or the indices. How does the exponent signifies in mathematics? Exponents will tell you how many times you will multiply the given number to itself. Example, if this is the case, 3 to the power of 2 as this may be read, or 3 squared, this means that you will multiply it 2 times to itself. So that is 3 squared. If you have a variable like 8 to the power of 5 or 8 to the 5th power, it means that you will multiply a 5 times to itself. So that is a times a times a times a times a. Now, how about if you have 2 different variables? Let's say x cubed, y squared. Now, in this case, it means that you will multiply x 3 times to itself and you will multiply y twice to itself. Easy, right? So that is the concept of exponents. But do you know that there are 5 rules pertaining the law of exponent? These 5 rules will help you how to manipulate everything that you will encounter in terms of exponents. So, what are these 5 rules? Okay, math learners, here are the 5 rules pertaining to the law of exponent. The first one is the product rule. The second one is the quotient rule. The third one is the power rule, in which the power rule has 2 sub-rules, that is the product to power rule and the quotient to power rule. And we have the fourth rule, that is the negative exponent rule. And last but not the least is the zero exponent rule. Question is, what do these 5 rules state? Rule number 1, the product rule. If you are multiplying 2 expressions with the same base, let's say a to the power of m times a to the power of n, what you will do is you just copy the base and then add the exponent. What does this mean? Example, if you have 3x squared times 4x cubed, since 3 and 4 are whole numbers and they are not the same base or the same number, then you just multiply them directly. 3 times 4, that is 12. However, x squared here and x cubed here has the same base, that is x. So therefore, you just copy the x and add 2 plus 3, that will give you 5, which will be read as 12x to the 5th power. Easy, right? Now, let us go to the second rule, the quotient rule. According to the quotient rule, if you are dividing expressions with the same base, what you need to do is you just copy the base and subtract the exponents. What do I mean by this? If you have x to the power of m divided by x to the power of m, what you will do is you just copy the base and then you subtract the exponents m minus n. But there is an exception to the rule. Make sure that m is greater than n, meaning that this number is bigger than this number. Otherwise, you will have a negative exponent. And in terms in the law of exponents, the final answer should not be expressed in the negative exponent. Okay? So let's consider some example. Let's say we have 12a to the power of 9 over 3a to the power of 4. So since these are both numbers, doesn't have the same base, so 12 divided by 3, the answer is 4. A to the 9 and a to the 4 here has the same base, which is a. You will just copy a and then subtract the exponents, 9 and 4. So 9 minus 4 is positive 5. Easy, right? Let's consider this scenario. X to the 4th power over x to the 6th power. How do you simplify this scenario? So what you will do here is, if you copy the base, okay, and then 4 minus 6, that is negative 2, then you are not yet in your final answer. So what we'll do is, you just get the reciprocal of that one, and that will become 1 over x squared. Now, this may become confusing for you, but let me show you a technique so that you can have a full understanding about this. Let's consider the expanded form. X to the 4th means you multiply x 4 times to itself. X to the 6th means you multiply x 6 times to itself, right? Okay. Now remember, in dividing, you are canceling the same factors. These are all factors pertaining to the numerator and denominator. You can cancel 4x's in the numerator and 4x's in the denominator. So, if you cancel this one, basically, nothing's left here in the numerator except 1. Of course, that is the numerical coefficient of the variables, right? Okay. And then, you still have 2x's in the denominator, so that is x squared. And they are just the same. Okay? So, to make the long story short, always make sure that your final answer has no negative exponent. Easy, right? Now, let us go to the third rule. Okay, for the third rule, we have the power rule. Now, what does the power rule states? When an expression with an exponent has been powered up even more to another exponent, then what you will do is you multiply those exponents. What does that mean? If you have a to the power of m, and then this is powered up to another exponent to the power of n, what you will do is you just multiply m and n, and that will give you a m to the power of n. What does this mean? Let's say you have x cubed y7 z to the power of, let's say, 4. So what will be your final answer? So if this is the case, what you will do is you just multiply the exponents, okay? So x cubed now will become x to the power of 12, y to the power of 7 will become y to the power of 28, and z to the power of 1, or just z, will become z to the power of 4. And this will be your final answer. Easy, right? Now, what does the other two subtopics or subrules mean? The product to power rule and quotient to power rule. Now, for the product to power rule, basically, that is a combination of the product rule and the power rule. Example, you have a to the power of m, and then this is powered up to another exponent, and then a to the power of, let's say, p to the power of q. So basically, what you will do here is you just multiply first the powers. So since this is the first group, that will become a to the power of mn, and then the second group will have a to the power of pq. But since they have the same base, you can have a to the power of mn plus pq. Now, I know this might seem very confusing, but let's consider one example. Let's say you have 2xy squared to the power of 2 times 2xy to the power of 4 to the power of 3. Okay, so how do you solve that one? You need to solve this one first using the power rule. So this will give you 4 because 2 squared is 4. Then this will become x squared because 1 times 2. And then y to the 4th. Okay. And then we have here 2 cubed. 2 times 2 times 2, that will give you 8. X to the power of 3, that will become x cubed. y to the fourth to the power of 3, that will give you y to the power of 12. Easy, right? So now you will apply the product rule, and that will give you 4 times 8, so that is 32. X squared, x cubed, they have both the same base, so you copy the base, you add the exponent, 2 plus 3, that will become 5. And then y to the fourth and y12, they both have the base y, so you add the exponent, 4 plus 12, that is 16. And this will be your final answer. Easy, right? So now let's go to the quotient to power rule. For the quotient to power rule, the notation is very simple. If you have a to the m over a to the power of n to the power of, let's say, p, if you simplify that, that will become a to the power of mp over a to the power of np. And since they have the same base, that will become a to the power of mp minus np. Easy, right? So let's consider an example. Let's say we have 9x to the power of 5 y 6 over 3x squared y to the fourth, and this whole expression is powered to the second power. So how do you simplify this one? There are two ways. You can simplify first what is inside the parenthesis, or you can apply the power rule. Okay, either way, the answer is still the same. Let's consider first simplifying what is inside the parenthesis. So 9 divided by 3, that is 3. X to the 5 and x squared here. So you just copy x, you subtract it. So that is 3. y6, y4, you subtract 6 to 4, and that will give you 2. And then since this is powered up to the second power, then the final answer will become 9x, 3 times 2, that is 6, 2 times 2, that is 4, y4. So this is your final answer. Now, question is, so what if you start first with your power rule? So if you apply the power rule here, this is another method, okay? So 9 squared, that is 81. X to the 5th power to the second power, that will become x to the 10th power. Then this will become y to the 12th power. You follow? Okay. 3 squared, that will give you 9. X squared to the second power, that is x to the 4th. Y 4th to the second power, that will give you y 8. If you simplify 81 and 9, that will give you 9. X to the 10, x to the 4th, that is x 6. Y to the 12 over y to the 8, that will give you y 4th. And they are just the same. Easy, right? So now let us go to our fourth rule. The fourth rule is the negative exponent rule. So I have already given you some pointers on this part. So what does the negative exponent rule mean? Let's say if you have a to the power of negative m, what you will do is you just get the reciprocal of that expression, and that will become 1 over a to the power of m. Easy, right? Now, what if you have 1 over a to the power of negative m? Then you get the reciprocal of that one, and that will become a to the power of m. Easy, right? So, let's consider an example. So, let's say we have 10 x squared y negative 5 z 4 over 2x to the negative 4 y cube z 6. So what is the final answer? So since in this example you see negative exponents, I will teach you one trick. If you see negative exponent, what you will do is you just transfer them to the other side. If the negative exponent is in the denominator side, then you transfer it to the numerator side. If the negative exponent is in the numerator side, you transfer it to the denominator side, and vice versa. Then how do we do this? Okay, so first let me transfer first the negative exponent. So that will give me 10x squared, and this x to the fourth, I will transfer it. So this will become x to the fourth This y5, I will transfer it below. So y5. And then, what remains here is the z to the 4. Okay. So, in the denominator side, what remains is the 2. My x is already transferred. That is here. My y cube is still here. And the z, 6. Okay, now, what I will do is I will simplify the given. So, 10 divided by 2, that is 5. X, there are 2 x's here, but there are no x in the denominator side. So, I will apply the product rule. So, x squared and x fourth, that will give me x to the 6. Then, that is z to the 4th power over. So, since I have already divided this one, so this is already finished. So, in the denominator side, I have y to the 5th and y cubed. And there is no y in the numerator. So, I just copy y to the 8th power. And then, z, 6. Now, as you can see, both my numerator and denominator has the variable z. So, I can still simplify this one, giving me 5x to the 6 over y to the 8. Since z here is bigger than this one, so if I have 4z here and I have 6z's here, so I will cancel all the 4z in the numerator and in the denominator. I will still have 2 more z's in the denominator side, and that is my final answer. Easy, right? So now let us go to our final rule, and that is the zero exponent rule. And now for the last but not the least rule, the zero exponent rule is considered to be the easiest rule among the exponents. Why? Because by definition, any number or expression or variable that has an exponent of 0, the resulting answer is equal to 1. What does this mean? If you have a to the power of 0, the answer is 1. If you have 5 to the power of 0, the answer is 1. If you have 10 to the power of 0, the answer is 1. If you have x to the 0, the answer is 1. So, any variable or number that has an exponent of 0, the final answer is 1. But let me correct some confusions to you. If you encounter this one, 3x to the power of 0, the answer here is 3. Why is that so? It's because 0 here only pertains as an exponent of x and not 3 as a whole. So therefore, if I simplify x to the power of 0, that will give me 3 times 1, which will result to positive 3. But if the given is 3, the quantity 3x to the power of 0, then if I simplify this, the final answer is 1. Easy, right? So I hope you have understood this topic about the law of exponent. This is very important, my dear math learners, both in the grade 7 and in the grade 9 level, because this is a foundational topic for future mathematical computations. Now, this is the time that I will challenge you whether you have understood this topic, and here it is. Okay, math learners, I hope you have a wonderful time about our topic for today. If you do have some questions about this topic, do not hesitate to put your inquiries in our comment section below. Thank you for subscribing, liking this video, and sharing this to your fellow friends, classmates, and schoolmates. This is still your free access math teacher, Ash. And always remember, it is fun to learn mathematics if we are together learning. Thank you so much, God bless, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.